So I'll just quick intro here. My name is Clay Charnick, and we're excited to have a guest presenter today for the webinar, Matt Lucas, who recently finished here in Hawaii, the NREM department, his master's, and actually we'll get a little bit about projects later on in this presentation, but he'll be talking about land cover maps for fire and land management in Hawaii, so what products are out there, and how they're used. And I'm going to turn it over to Melissa to kind of give a little overview of the context here, how we're able to provide this webinar.
Great, thank you, Clay. I'm Melissa Coons. I'm the coordinator for Pacific Fire Exchange. And really quick, just a couple of logistical things. One, we are recording this webinar, so just a heads up on that. And second, there should be a little control panel in your, well, there should be a webinar control panel on your screen where you can raise your hand or ask questions. And Matt can indicate whether he wants to take questions all at the end or if he'd welcome questions in the midst or possibly during pauses in his presentation. But just be aware that those are tools you can use to contribute your questions and insights and knowledge as part of this webinar. All right, so to dive in, the Pacific Fire Exchange is part of the federally funded Joint Fire Science Program Fire Science Exchange Network. And the overall goal of JFSP and the network is to better connect researchers and managers for better fire science and better application of fire science for good wildfire outcomes. And that varies by region, and so the country is split into 15 different regions, and we represent the Pacific. So in the next slide, we just show a quick summary of our founding partners. If you could, thank you. Including Hawaii Wildfire Management Organization, the U.S. Forest Service, Institute of Pacific Islands Forestry, and the UH Cooperative Extension. In the next slide, our goals, reduce wildfire threats to the ecosystems and communities in the Pacific through facilitating knowledge exchange, fostering collaborative relationships, and getting out the best available research. We hold webinars like this one, we host field trips and workshops, we produce fact sheets and research briefs. We also have an email newsletter and our website. So we welcome your participation in all of these and your feedback on all of these, which leads me to the last slide I have here is please help us better serve you by completing the feedback survey once the webinar is complete. So thank you for being here and thank you for your feedback at the end of all of this. And I guess now we'll transfer the presentation over to Matt.
Hi everyone. I was introduced before, but my name is Matthew Lucas, and I'm a recent master's student graduate from NREM here, and I was actually Clay's student, so he's pretty familiar with this work. But what I really want to talk to you, I'm going to talk to you a little bit about my work, but what I want to talk to you about is just the land cover maps for fire and land management, because my project ended up creating an addition to the suite of land cover maps that we have for Hawaii, but in the process I definitely delved into a lot of the available data out there. So I kind of wanted to help people kind of get an idea of what's available out there, what the intended use is, and different ways you can access it and maybe start to use it, and then really lead into a discussion where I kind of show the work that I've done, and as we start to develop that into a product for people to use, maybe go into that. So, I mean, just a general overview. I just wanted to give the you know, the context of land cover, what we're actually talking about, and then I really want to go over the available GIS products for the Hawaii and U.S. affiliated Pacific Islands. And kind of for each one what their benefits are, what their attributes and intended uses are, where you can access these products. And then I want to go into an introduction of newly developed dynamic fractional cover land cover product, which is the product that was developed in my thesis, and which really has focused on identification of areas of change and rates of land cover that have occurred since 2000. And then I really want to have a discussion or look at some potential applications, just real briefly, show you some potential applications and kind of give you some ideas of how this stuff can be used. And hopefully that'll lead into a discussion about land cover product applications and interfaces. So without further ado, what I want to start off with is, because GIS data, there's all kinds of GIS data out there. I want to limit it down to what we're actually talking about. So what we're not talking about is national or global data. We're talking about the Pacific. So there's a lot of this data does exist on the national scale, and we're also not talking about raw satellite imagery, and we're not talking about aerial imagery or any of that stuff. That a lot of that stuff was used in development of these products. We're also not talking about FODAR, LIDAR, point clouds, so that's raw data, again, that can be used to make some of these land cover products. And we're not talking about species ranges or locational data or climate, although all of those, again, can go into developing your land cover product. And the same thing with fire and disturbance, zoning, or land use. And so that's just the big clarification I wanted to show, because land cover, so that really brings us to what is land cover, and land cover is just really the types of features that cover the surface of the earth. And so the difference between land cover, I just mentioned land use, the difference between land cover and land use is land cover captures the physical state of land resources, whereas land use denotes how land is being used. And this is a graphic that I took from the Landfire website, because they really kind of nailed it here. But they kind of talk about the attributes of land and the attributes of fire, but you could apply that to any kind of disturbance or function. And then they really talk about where those overlap and why the importance of just knowing this land cover in the context of fire is really important. And that all of those reasons are right there for planning, budget, natural resources, decision support, and stuff like that. So speaking broadly, though, when we talk about land cover, all of those things that I just excluded as far as data, they really do influence what the actual cover is, because we have disturbance that affects our land cover, we have land use that affects our land cover, we have biological processes. And, you know, we see these can take many different shapes and forms. These are just kind of some context of examples here that are happening in Hawaii. And so even though we are talking about land cover, sometimes these types of things creep in, and they always need to be put in the land cover. Kind of needs to be put in the context of these drivers. So now, as far as the land cover products that we're actually going to talk about today, I'm going to go over the Hawaii gap analysis. I'm going to go over the Landfire product suite. I'm going to go over the NOAA CCAP, and then I'm going to introduce the my product, which for now the working title is the Unmixed Fractional Land Cover. But that's subject to change. So, so the gap analysis. Well, so this is just the intro slide. This is what the website looks like, and the link is in the talk here. All the links are in the talk, and we'll make sure that everybody gets those if they want to. But basically, when you go to the website, this is what it looks like. And when this is really right here is where you get the data, and that's I'm going to kind of highlight that right away, because everybody wants to get to the data or look at the data. So these two buttons right here, you can download the data and by state. And then you can also go look at it in a viewer. If you don't want to download it, you just want to check out what it's available. So, but that leads us to the mission statement. So what is the gap analysis? Well, this is the mission statement of GAP. GAP works to ensure that common species remain by identifying those species and plant communities that are not adequately represented in existing conservation lands. It's basically for conservation planning. And as such, it really adds a lot of ecological relevance to the land cover products that it produces. And so here's kind of for Hawaii. This is more the Hawaii GAP product, because the GAP product exists for all the states, and there are several iterations of GAP products for other states, but for ours, we have one GAP product as of right now, and its attributes are that it's the main Hawaiian Islands. It's from 2001 satellite imagery. That was the data that was used to drive. It's been revised a couple times, but the data that is at the core is 2001, and that is from Landsat imagery. So that means it's going to be 30-meter resolution, and it has 48 ecologically based cover classes. And its intended uses are ecological mapping and conservation planning. And so because of that, what its real benefits are is it's ecologically relevant and it's very widely used. A lot of conservation organizations here use the gap analysis to look at landscape scale stuff. And for the most part, it's pretty good. Obviously, its limitations is it's only one time step and it's 17 years old, so it hasn't really captured too much land cover change or zero land cover change. And so, but it does add a really good wealth of knowledge as far as communities go and as far as when you're talking about native species. And so that's where the access to the viewer and the download is. And this is actually just a little snapshot of the viewer here. And there's a better link for the viewer. But you can kind of start to see some of the classes here in the legend: closed koa ohia forest, closed ohia forest, koa forest. They kind of actually are attaching species name, dominant species names onto the land cover themselves. And so, like I said, we're not going to talk about species ranges. I mean, in effect, this product is aiming at getting at species ranges in the form of land cover. So again, there's some of that overlap when we're talking about land cover. And this is a really widely used product in Hawaii, and it's pretty good. And it fits nicely into the next into the Landfire product, which is the next one I'm going to talk about. And that's because the gap was kind of the starting point, I think, for a lot of the Hawaii's Landfire products, and probably elsewhere's too. And those two products are somewhat integrated. And so Landfire's mission is to provide agencies and managers with a common all lands data set of vegetation, wildfire, fuels, information for strategic fire and resource management planning. So this one is really tailored towards fire and land management. And because of that, it has a lot of data assigned with it, and it has several years along with it. It's an active product that's always being used, and because of that, it's really good as far as thing. Again, this is where you get the data when you go to the main website. You can download it, access it there. You can also where it says data on the top and it has the different reference, disturbance, vegetation, fuel, fire regime, topographic. Those are all buttons that just shortcut to those types of data. But if you want to look at the data online, you can go to the access button in that red circle, or you can go to the download data mosaics. And the download data mosaics, I'll show a screenshot of that, but there's a lot of data on there. So as far as the attributes of that product go, it is the main Hawaiian Islands. It also is American Samoa, Guam, CNMI, Federated States of Micronesia, Palau, and Marshall Islands. And so this product is really great because it has the largest spatial extent, and it really does cover pretty much. I think it covers all of the PFX area, and it doesn't just have one map for each of those areas. It has at least two for each of those areas, and so that's really great too, because there is a little bit of change, a little bit of update that's happening. So and that brings us to the years that it's available. I put it in, I highlighted it here, but you can see, bolded it, sorry. It's 2001, 2008, 2012, and 2014, and 16 I think is supposed to come out very soon. And it's mostly Landsat data, but it has, because it's a fire-driven product, there's often additions and meetings. There's regular meetings, and maybe some of the webinar attendees can actually add more knowledge of how the process goes, or what timelines on updates and stuff like that. And I'm not a Landfire expert, but I've used it enough. But essentially, there is a lot of updating of the product that actually goes with where known fires were. And a big portion of Landfire is actually keeping track of where fires happen. So it's not just land cover. Land cover is one part of the Landfire product, but there's several products within that. They host topographic data. They host disturbance data from fire, different ways of viewing land cover. So its intended use is for fire and disturbance mapping, management, and modeling. That'd be fire modeling. And its benefits are that it has several time steps. It's the most coverage for the U.S. affiliated islands. It's very widely used nationally, and it's made for land and fire management. And that means it's built to plug into fire models, into several models. And there are 25 vegetation classes, and again, it's 30-meter resolution. So it's the same resolution as the GAP, and a lot of those classes will kind of fit together. And I think that in the context of Hawaii, the GAP analysis was really added a lot of information for land fire to get going, and continues to. So its limitations, as far as I can tell, is it's kind of opportunistic where change happens, and so when they do periodic updates, it might just be where there's fire, where there's known large fires have happened, and because of that, there might be some assumed fire changes or outcomes. And so that doesn't mean that they're not doing quantitative analysis to actually push out new products and stuff like that. I just know that there are some of those ad hoc add-ons as far as land cover goes. And it seems like because of that, that they really detect a strong and rapid change that you would see from a fire, from large fire impacts and stuff like that. So there's the data access there, and we can take a look on it a little bit. This product right here is the, or when you click on the vegetation link on the top there with the data, you will see all of these products that you can download, and these are decent descriptions of them. If you dig into the website more, you can get even more. You can get larger descriptions and stuff like that. But essentially, as far as a product that I'm really familiar with, is the existing vegetation type, and that's the one that's the most analogous to the GAP land cover. And they have some shared class names, or almost shared class names. And that essentially is your native shrubland, your native forest, your alien forest, alien grasslands, and stuff like that. But they also have cover, which is very important for understanding fuels across the landscape. And I'll show an example of that later on. But as well as height. And so all of those things are very, very important for fire models, and just kind of understanding where your continuous coverage fuels, where are your ladder fuels, where are your large fuels and stuff like that. So you can kind of start to understand the diversity of fuels across a given landscape when you look at it. And that's really the way that it was designed. It also has, they really go into the fire history and stuff like that, and so you could dig into there. And you can kind of see that here. This is when you click on that other link that I showed you in the beginning. This is their matrix. I don't know if everyone can see all this, and I don't expect everyone to be able to read all of this, but basically you can just see that the big brown column on the left-hand side has all of their products on there, and they don't have all the products for all the time frames and all of the extents, but they have most of them, and they do have really interesting stuff like I said, the canopy density, base height, all kinds of stuff. There's a lot more metrics than a lot of other land cover products give you. Because of this, you can kind of get overwhelmed, but if you find you need it to do fire modeling or something like that, or you want to look at a certain aspect of land cover, this is really great, because at least it starts to give you some of those answers that maybe other land cover products won't. I mean, really, this is the time frame, as you can see here. So they have those are the 2001, 2008, 2010, 12, and 14, and then this is Hawaii. This column right here is Hawaii, and you'll see that across all of them. But there's the affiliated islands. So they have it as IA, and that doesn't start till 2010. So this is an example of their viewer here. And as you can kind of see, this is, I believe this is the existing vegetation height. Personally, I find this viewer just a little bit clunky, but I think that if I did some more training on it or poked around in it, it actually, again, allows you to access pretty much all of the land fire data as you want. You can click around, you can zoom in and out to where you need to go and everything like that. But I tend to just download the data and then start to look at it that way. But I'm a GIS person, so. And if you want to just save space and make sure you know what you're getting, the viewers are always really a good way to do that. So, and then I wanted to just bring up a little bit of news about the gap analysis and land fire. They've always worked kind of in concert, but they're really going to be merging together. And essentially, they're teaming up to deliver a new land cover product or a detailed land cover product that supports wildfire and species conservation. So that's really great because there's a lot of overlap in those two goals. And they're going to be working on a strategy to do this. So right now, I think that all of the verbiage that I was reading, preparing for this, basically said it was in fall of 2016 they were going to start some testing of different ways to create a remap and be able to provide these biennial updates, which is really important for the GAP to have biennial updates. And so the biennial updates, again, allow you to analysis of vegetation change over time, fire dynamics, and all kinds of stuff. So this is just an update, and there isn't going to be a name change, or there is a name change of the National Gap Analysis, and you can read about that on the GAP website. It seems like there's more information about happenings as far as the federal level of namings and the national data standards for land cover products on the Gap Analysis website if you're interested in that kind of thing. So, okay, we're gonna kind of not change gears, but we're going to take a look at another product here, and this one is less so integrated with the other two, although I suspect in Hawaii there's probably a little bit of overlap as well. But this is the CCAP, which is the Coastal Change Analysis Program. So this is a NOAA program, basically, CCAP was intended to map intertidal areas, wetlands, and adjacent uplands. And so, as a mandate, I believe it's around 200 miles. They mapped everywhere nationally, 200 miles from a coast, including the Great Lakes. And so, for Hawaii and Florida, that is the entirety of the state. And so that provides us another statewide product. And the CCAP is really considered a coastal expression. They kind of pride themselves in saying they're a coastal expression in the national database, and that they tend to update every 5 years to do cross comparison and document land cover change over time. And again, this is the CCAP, the main CCAP website. If you Googled CCAP, you'll get like 4 websites that come up with trainings, with the digital atlas, and everything else, but this is the main one that tells a bunch of information, and there's really good links on here too, and I'll kind of show a little bit of that later on too. So yeah, and that's what I wanted to highlight here is if you go up here, the tools and training, they do have some really cool tools. I'll show one really quick, screenshot of one really quick, and then I also show a little mini training, but they have other trainings too because they really want people to use this stuff for change detection and stuff like that, or quantification. So the NOAA CCAP, it covers the main Hawaiian Islands, American Samoa, Guam, and CNMI. And it goes back to 1945-46, but that's only for parts of CNMI. And then for the rest of that extent, for mainly Hawaii, it's 92, 2001, 2005, 2010. And so we're due for a new update. I didn't see it on their website, but I feel like I've seen the data. I've acquired the data, so I don't know if there's preliminary stuff of 2015 around there or not. But I imagine it will be coming out pretty soon. It's 25 classes, 25 plus classes. I say plus because there's some classes that don't apply to Hawaii, like tundra and stuff like that. But it's a wetland vegetation focus, so it's kind of an estuary wetland, a hydrology approach as far as how this land cover is affecting the coast. And they make mention of that their nomenclature for their naming is not the standard national standards that they fit within that, but they add more detail as far as them being a wetland and a coastal product. So its intended uses is for coastal change, hydrological and wetland, and coastal mapping. And its benefits are, it really has the longest time steps. It has a bunch of time steps in years that we don't have other land cover products. And it is widely useful for urban, coastal, wetland change. I mean, and I'm kind of talking about in Hawaii, but I guess most people live near the coast, so that I would imagine that nationally that's probably the case too as far as the urban goes. But its limitations, again, are that change is focused on these coastal areas with the most impacts being these estuary areas. That being said, I have noticed that they did document some agricultural land cover changes in Oahu and stuff like that. So I do feel like they are capturing some other changes, but I've looked into known areas where I've seen invasive species, colonization, and different land cover change during their time frames, and it wasn't completely captured in their data. So their data access, that first page I showed you is the info right there, and then online they have the CCAP Atlas is really this slick online. It does a bunch of has a bunch of functions, and it's really slick. And then the download is right there. And the download is really nice because it's organized really well. You can go look at the different data. Oh, I forgot to mention too that it's 30-meter resolution in the earlier time frame, but it hosts for the last 2 time steps in Hawaii, and I believe in CNMI as well. It has high resolution. So the high resolution is a 2.5 meter, around 2.5 to 3 meter classified land, and that allows them to do high resolution land cover change. And so that's really interesting. They incorporated QuickBird, I think, in 2005 and Worldview in 2010. And so those 2 imagery products allowed them to increase their resolution tenfold. And so that's another benefit that this product has over the other 2, and actually over my product as well. So this is the digital atlas when you look at it. So this is nationally, and then on the left-hand side, you can get drop-downs for state or territory, for the county or island, or you can select on a map. And when it selects on a map, it brings up the Kanos or Hawaii or CNMI or Guam, and you can select all of those. And just a little bit, selecting on Guam, the viewer is really focused on change. So you can look at the land, just the general land cover and stuff like that too, but you can also look at the change, and it produces all of these statistics on the fly, which is really cool. So as far as what they've detected in Guam between 2005 and 2011, you can see the time slider on the top 2 that allows you to slide stuff back and forth, and that 9% of the island of Guam has undergone change. And then you can't really read it too much, and it doesn't make sense because you don't know, the codes aren't present, but it has statistics about where actually that change occurred. And so there's 2 bars for each of the time steps, and those are different classes that you start to see. I think they're the broad classes. And then it has gains, losses, and gains of those different classes too between the 2 years. So this is the reason I show you this is just because this is an interface here. This is a really slick interface, and because they have so much change data, and that's what they're really focused on. I kind of wanted to introduce everybody to maybe get some ideas about how different ways you can show land cover products and change that are from that. And then they have different stuff too, like you can highlight this is forest cover, so you know how much of the percent of it is in forest cover. It looks like they had a very small gain in forest cover during that time frame. So this is like the red is forest cover loss, and the green is forest cover gain, and then the 2 pie charts are the comparison in between the 2 years. So it just gives you a little bit more in depth about what types of classes are interchanging between the 2. Okay, so this is gonna I'm gonna lead in now. Now that we've kind of talked about change and stuff like that, that's a nice lead into the work that I've done and that we're kind of continuing to beta test and validate. But right now we're calling it the unmixed fractional land cover, and unmixed is referring to the linear spectral unmixing algorithm that's at the core of the algorithm that we use to actually create this product. And so the Unmixed Fractional Land Cover project has produced statewide annual maps from 1999 to 2016 of proportional percent cover of forest grass and bare earth from our archive Landsat imagery. And then change detection was performed on this data on all 16 of these annual maps, and it used because this data is a continuous number and not a discrete value, we could actually use statistical trend analysis to be able to highlight areas of change. And it allowed us to do this statewide and get the total extent, the rates, and the outcomes of land cover change. And we also are starting to, we're starting to attribute that to spatial land management history, and part of us having discussion with people in this webinar is to try to understand how they would maybe envision attributing this to management history that on their on places that they have more knowledge about. And so here's the attributes about the product. It's the main Hawaiian Islands. It's annual from 1999 to 2016, but that excludes the year 2014, and that's because of a technical issue where Landsat 8 was launched and Landsat 7 went into a conservation mode and did not collect imagery from oceanic islands, which included the main Hawaiian Islands, and then it was turned back on in 2015. So we have a data gap for that because this algorithm is really only parameterized and ran and validated for Landsat 7, although expansion onto other satellite platforms is possible and may happen in the future. And so what it actually produces is it only has 3 classes, but those classes are continuous numbers from 0 to 1, representing fractional cover, or percent cover if you times that number by 100. And so those 3 classes are grass/fine veg, forest, woodies/coarse veg, and bare or unvegetated areas. And so every pixel has essentially a ratio of all 3 of those, or a sum to 100% cover of each one of those. So it's 30-meter resolution, but it's providing sub-pixel information, and so that's what makes it very different from these 3 other widely used products that I was just introducing. Its intended use was to quantify the impacts of land use and management in terms of these broad dynamic covers. And because of that, and because it has 16 annual time steps and provides this sub-pixel information, it really allows us to look at transition rates and do like gradual transition as far as like invasive species creeping into an area, maybe you know, the loss of forest over time within an area and stuff like that. And so these are less dramatic land cover impacts and more of a gradual process. As well, it does capture dramatic ones, and we're seeing that in the results as well. And because it's these continuous numbers, allows us to do this statistical trend approach. Its limitations are it's still in beta testing, and it lacks details on species composition. Although, because we have so many products that have species composition, and because we have such a good user base of these products and of land management as well, it's very feasible that we could actually just attribute the species and the more detailed ecological data on top of this data that we are producing. And so that's something that we're talking about and trying to figure out how we could go about doing that. And another limitation too, I guess, would go down to the data access, which is that this is a really cool product, but it's not quite available yet. And so we're hoping to release it in 2018. There's a publication in the works, and we have a little bit of money to start to build a website and get it at least hosted. And that's part of the reason we wanted to capitalize on this opportunity of this webinar, so that we could start to talk to potentially end users and really get their feedback about how they envision using this, or what would be good or isn't needed, or something like that. In the meantime, if there's particular area or something of interest that you want, or if you have a case study you think that this would be useful for, feel free to email me, and my email is right there. It's mplucas@hawaii.edu. Now, I'm going to just kind of go in, because I did describe it, I went through it and everything like that, but I'm going to go through with a little spiel about it. I just felt like this is kind of needed, because it is a kind of a different product. So, I mean, Hawaii, as we just learned, has all these several land cover products, and they have multiple temporal snapshots for the most part. But the problem is that the classes are discrete, and they're subjective based on the intended use. So to address this kind of issue, and to kind of address this land cover change that we're seeing right here, this is Pu'uvava, and this is from Landsat, image 1999 and 2016. On the red arrow, you can see in the earlier image and in the later image, the loss of forest cover. And that's actually an invasive tree that is being controlled. And then you can see on the green area a gain of forest cover, and that's native reforestation through restoration action. And so both of these processes are happening across the landscape, as well as all those other ones that we mentioned in the beginning as to what affects land cover. And really, we don't have this type of change is largely going missed in some of these land cover products. And so what we aim to do is we kind of wanted to come up with a new approach to kind of address this and start to look at, you know, doing these accounting issues of different cover. And so we aim to use every Landsat image in Hawaii to map past percent cover, and then having the repetition of all of these maps, identify areas of rates of land cover change, and then attribute that land cover change to causes and start to catalog it. So we did this using the Google Earth Engine platform. And so the Google Earth Engine platform is a free online platform that's hosted by Google, and it's a cloud-based remote sensing platform that has lots of data that they've collected from, basically it has every single Landsat scene ever collected globally, as well as all kinds of other satellite imagery. And it has more than 5 petabytes a day. I think it's 6 now, and it basically gives you supercomputer computation and data access, big data access at your fingertips through a internet connection. So you could be coding this stuff and accessing, you know, terabytes and petabytes worth, 5 petabytes worth of data from a web book or an iPad if you wanted to. And within it, there is this application or this methodology that's called spectral linear unmixing. And so spectral unmixing, what it basically does is for each pixel, it returns a proportion of cover. And so there's 2 examples up there where you have your different spectral signatures for your different land cover types. But sometimes you have pixels, like in the example on the right-hand side, where you have a mixed pixel. And so what spectral unmixing does is it would produce, if you only had a green cover and a red cover, it would produce 2 fractional cover maps, where essentially you would have a value of 1 for all the red cover and a value of 0.5 for the mixed cover there. And so that's essentially what it does, is it uses these pure pixels to train and to parse out these sub-pixel proportional cover. And so for Hawaii, this is basically what it looks like statewide. And so this is the legend kind of on the left-hand side, where essentially imagine every pixel within there has to fit somewhere within that triangle, and that triangle, the far edges of each one of those triangles would be 100% cover. And then anywhere in between there would be a proportional mixture of those 3 cover types. And they're not limited to only being tree cover, only being grass cover, or bare earth cover. There are other types of cover that fit within that. So that's why we say when we talk about tree cover, or what is represented in the green, it could be coarse vegetation. It could be very dense shrubs such as gorse or something like that. And grass cover, we call it fine vegetation, because that could also include sparse shrubland or something like that, or Halicoa, Lucina areas. So anyway, and so for this is what it looks like when you zoom in. This is high resolution aerial imagery with the unmixing laid on top of it. And as you can see, it matches the actual landscape pattern pretty well. This is the kind of information that we're getting from each one. We're getting a proportional cover of each pixel, a sub-pixel information of those 3 covers. And because we have this for 16 years, it allows us a lot of information. And it allows us to do things like using statistical trend analysis to highlight areas of change. And so I'm going to just show you really quickly some of the change we've detected on the east side of the Big Island, because it's a really dynamic landscape with all different types of change occurring in one small space. So it's really nice for a presentation. But essentially what you're seeing here is the brightness color is showing which way the trajectory or the land cover outcome that we've observed during the 17-year study period. And essentially, the brighter the color, the steeper the slope, and the actual color itself is recognizing which way it's actually going. So it's the gain in cover, or the positive slope towards that cover. And so when we start to attribute anecdotally what we're seeing here, we can kind of start to see stories come together. And so we see woody gain, woody grass to forest, woody gain where restoration is occurring, but we also see woody gain right adjacent to it where invasive gorse is covering abandoned pastures. And those are both land cover changes that are happening on abandoned pastures, where you see grass increase as we see loss of forest due to rural development in the HPP area of the Big Island. We see bare lava flows dominating what was previously vegetation. We also see there's an indication of fire. I believe that was a controlled burn in Hawaii Volcano National Park. Some woody gain due to invasive trees, and some grass gain over bare areas. And so from a fire context, if we really think about this, we're seeing fuels change, we're seeing landscapes change, and we're seeing through these slower processes, we're starting to see flammability increase or decrease across the landscape. And we have this data for statewide. So this is Maui. The only reason I show Maui is because it's a different island, and it's about to go through, well, it's already going through a lot of change here, but because of the decline of sugar, we expect to see a lot more grass increase across that whole Middle Valley area. And our method captured really well the grass increase in some of these abandoned agricultural areas that have been abandoned since the beginning of our study period, but we are probably going to start to see that happen more and more. So should I do the next thing, or do you think I should do a demo? How are we doing on time?
We've got probably another minutes or so.
Okay.
So you want some time for questions.
Okay, all right.
You leave that to the end.
Okay, all right. If we have time, I'll show a little demo. We can drive around on it. But so just to reiterate and go over all the data that I've covered. So the main Hawaiian Islands is above this timeline, and all of the affiliated islands are below. And so the Hawaii gap analysis, represented by the green triangle, is 2001 is what the data is sourced from. Land fire is, for the main Hawaiian Islands, is from 2001 to 2014, and it has five actual products that it's pushing out for the main Hawaiian Islands, and it has 3 for Guam, American Samoa, CNMI, Federated States of Micronesia, Palau, and Marshall Islands, and those go back to 2010. Now the CCAP data has the longest time frame. It goes the furthest back, but it has a big gap in data, and so you can see that goes back to 1946. Obviously, that line's not to scale where it turns to dash, but they have the 3 time steps for the territory islands, and then they have 4 time steps for the main Hawaiian Islands with a high resolution imagery at the end. And so the unmixing data here, it runs from 1999 to 2016, and it has 16 time steps because it's annual. And that allows us to kind of get more of a granular temporal understanding of how this stuff's varied, and again, it allows us to do more of a statistical approach to land cover change. Those breaks are actually arbitrary as far as how the data was made. It was made seasonally on a hydrological 3-month seasons, but there's a lot of cloud contamination, and that data, when you start to look at inter-annual variation, it's really another thing. So we boiled it down to annual just to look at change, but there's more to the story, and there's potentially more data in there. So I just really briefly, I'm going to go over some really brief applications of this stuff. So obviously you can map. This is a map that I believe is hosted on the PFX website, and this is land fire, but it's a very broad vegetation. I believe it's the EVTLF, and so it's just their most broadest classification. We tend to like that because when you're making a map for visual purposes and stuff like that, if you just wanted to show something on an island-wide scale or something, that's a really good one because it doesn't have so many classes that it's going to clog up your legend. And it really kind of makes sense as far from a fire management or a biophysical understanding of what's actually on the landscape. And so you can use that, and you can get more detailed, and you can clip that to say a fire. This is a Nanakuli fire from 2016. And so by clipping that data, downloading that data and clipping it to our polygon, and that polygon could be a watershed, it could be a management unit, it could be a disturbance such as a wildfire. We can actually really easily parse out the amount of area that burned, that was consumed in this fire. So along the same lines with mapping, there's also fuels mapping, and so this is the legend what I'm talking about. This is starting to become like really clustered. But if you look in there, the main take home, you don't have to process this whole thing. The main take home is that when you look at the tree cover, the shrub cover, and the herb cover, which are basically your fine fuels, your ladder fuels, and your canopy fuels, you really start to see that that they give very good detail from these percent class bins across a gradient, and so that's what's really important for understanding and doing fuels mapping. So, yeah, this is the land fire map. Sorry, if I didn't say that, I should have put the logo on there. But this is why the utility of land fire has really been developed for these fuels mapping, and this is kind of what it's intended for. So, I mean, if you have these products, what are some ways that you can actually use them? I'm just going to really quickly go through. So with all of these discrete land cover products, you can pull them into ArcGIS, and a really simple. This is a fire that happened in Nanakuli just a couple months ago, but on the Big Island. You can see that we have, I believe we're just using the gap, and we're using the community here. And so we have that class, that community composition class there. It's alien forest, alien shrubland, and such. And you can use that data, put it in there, and you can run this really simple tool called Tabulate Area, where you add the roster, you tell it what field in the roster to use. So it's got to be one of these discrete land cover rosters, and then you tell it which data set to be able to derive the data from. And so we use the fire, and then it will spit out a table that will give you your area. So this is square meters of the cover types, and so those are the only 4 cover types that occurred within that actual fire. So that's a really simple one, and again, that tool is called Tabulate Area, and you can read the documentation on that. It's pretty easy. And I also wanted to show you too that the online viewer does some of this. If you're trying to do change detection using this, again, that online viewer does it. But also, this is just on the main CCAP website. I'm sorry, this is on the main CCAP website. If you just scroll down, and under technical support, they have these really great. They just have a couple of really simple 2-page PDFs that tell you how to do different things. So they don't tell you how to do. They don't have the Tabulate Area. They have another workflow, which is clipping the stuff, but they also tell you how to apply the legend and stuff like that, and that's really good documentation to have. So now, as far as like the fractional cover, if that, if everyone was able to download that product and do that, it's a slightly different workflow because it isn't these discrete classifications, and so to do that, you really need to use zonal statistics, because the classes themselves are this continuous range of numbers, and so the tool is zonal statistics, and it's the same. You give it the polygon, you give it the cover. In this case, we're actually just looking at the forest cover. So you have to, if this is a 3-band roster, you have to isolate just one of the bands, and then we're taking the mean of that cover. So it's the percent cover of all of those pixels, the mean of all of that, and that spits out a thing. And so we have the mean percent cover of forest for this Nanakuli fire on the Big Island was 15%, and but that doesn't really mean anything. But if you know the percent of if you know the size of the fire, so I added another field there, and I just calculated, I times that 15% times the size of the fire, and it automatically told me that within that fire there was 239 acres of forest. And so that's a quick way to do that. And anyway, I was just a little demo of how to use this stuff. And do we have any time, or should we start a discussion?
Yeah, I think we should just ask questions.
Okay, so yeah, I guess we want to move on to the discussion now, have people ask questions or put ideas out there. If people know more about these products than I discussed, I didn't discuss everything, and I also don't know everything, so feel free to add knowledge. But yeah, we want to get some input on the best land cover product applications, different interfaces people kind of imagine for managers, and then kind of comment on if you have comments on the knowledge about these land cover products or something like that.
Yeah, and ways you guys can interact is you can either raise your hand and I can unmute your mic if you've got a question you want to just, if you're assuming that your computer has a microphone built in, or there's also a chat box. You guys can enter your questions directly that way, and I will read out the question, and then we can hopefully have an answer for you. So, I mean, I guess we just started, but there's any questions about what Matt presented on more broadly within the audience here?
Oh, Pablo has a question. Pablo, you're up.
Hello, can you guys hear me?
Yeah.
Yes.
Hello, hello. All right, Orlando Smith from Hawaii Wildfire. Thanks for the talk, guys, and I really love this product, Matt. It's great work. My question is there anything left to do with this product, like quality control or additional data and processing, or is it already at the final state that it's going to for release for next year?
Well, so it needs to go through, it's validated with the data that we could get at the time. It's validated really well for the size of the product and the variability that we tested it against. But I'd like to have it be a little bit more robust and kind of understand some of the, anecdotally, I kind of know a lot of areas, and I've kind of looked and seen some slight, I wouldn't say issues, but just I want to understand how the product varies. And so there's some tweaking and kind of understanding where different things happen. But essentially, I mean, the product is functional. You can use it to look at things, and I don't think it's going to change that much. There's no real like huge process we're going to take it through. We might be more strict about the number of pixels like per year that get in, as far as incorporating some landscape shade masks on the raw imagery, or making sure that we reduce the images to really ones that are geo-rectified really, really well. And so those kind of things need to be addressed and looked at. And then we need to do some more validation plots, particularly with the way that we detect change. So we did one. When you're doing the statistical method to detect change, there's a lot of decisions you can make along that way, because you're essentially doing a linear regression with these 3 different covers. And so we made a set of rules, and we need to kind of test a lot of the assumptions of those rules to see how they affect our outcome of change, and then how that lines up with where we have known change and stuff like that. And so that process, that iterative process of kind of doing sensitivity analysis of how the product is working, as far as just the year-to-year unmixed images, and then how the change detection that we've chosen, that we've first initially developed, is actually working. And once those kind of things get done and we publish it, then we will be pushing it out, and it will probably get tweaked a little bit each year, and hopefully it'll get added on to other platforms such as Landsat 8 and Sentinel. So
yeah, I'd say like the advantage of where we're at now with it is that, as Matt said, it validates well, and what he means by that is when we compare it to plots on the ground where we actually have measured % tree and grass cover, it matches up quite well with those ground measured plots. So it's essentially, we ground truthed it, and it does quite well. But for the purposes here, it's like we're trying to figure out how to analyze every pixel in the state. But if there are specific applications, if people are interested in specific areas that they want to look at, we have kind of like applications in our head about what you could do with this thing. You can look at any place you want, as Matt was saying, on the map, and look at this time change and see what's happening in that place, area of interest. For our purposes, the challenge we're running into is, okay, we've got 18 million pixels times 3 different kinds of cover for the whole state. How do you just sort through all of that and actually pick out where change is happening? And that's kind of a limit. It's a computational limitation at this point, and we're sort of stuck with the tools that Google Earth Engine provides us.
Yeah. Well, another question I have is, are you guys comfortable with releasing it now? Like, can I have a copy to play with just for now off the record?
Potentially. I mean, I think that we could give you a copy to play with off the record, but you couldn't put it on any maps or release it to anyone,
right,
or do anything like that.
Right.
Yeah, I mean, we're okay with that. The other caveat too is you can't go around and find all the places it doesn't work and then tell everyone that it's junk, because we need to
right.
to tweak stuff. I mean, you know, if you have concerns when you're looking at it or something like that, yeah, we can release it and give it to you. But we're still kind of actually packaging it up, so even that is probably just a little bit out. If there was this particular area you wanted to look at, we could probably make sure that everything's good for that. But yeah, something on a given out to key people could probably happen over the next couple months, I would imagine.
Not too bad. I can wait a couple of months.
Yeah.
All right. Thanks for the question, Orlando. We had a couple more. First is an easy one. Dwight Matsuwaki asks, can we get a copy of the PowerPoint? So, Matt, is that something that you'd be willing to share that we could send out to the attendees?
I'll turn it into a PDF so it's easier to email, and I think all the
just post it,
or the links. Yeah, we can post it too.
Okay. Yeah. Great. We can post it to the PFX website. Another question from John Marshall. It says, John Marshall from Haleakala National Park just wanted to thank PFX and a high five to Matt for his hard work. Looking forward to the web viewer of the product. We would be interested in a fuels map or woody change map for the borders between HALE and Nature Conservancy and the Poly State DLNR.
Yeah, and I've talked with John, and he soft confirmed a large woody increase that we saw just outside of the park that we think is dense clydemia expansion. But you can see a lot of change in that Poly area around the fire. Some massive and then actually a really rapid regrowth of that novel mainland fire adapted conifers that are in there.
We have another question from Julian Dundee. I'm wondering how you dealt with cloud cover in the imagery.
So the way that I dealt with cloud cover in the imagery was I used the data set that was in Google Earth Engine. It's not just raw satellite, it's not just the raw Landsat imagery. They have multiple copies that are processed at different levels, just like when you go to download it from USGS if you go to Earth Explorer or something like that. And they actually had 2 data sets available. They had one that was atmospheric corrected. It was the top atmospheric correction all the way to the ground, which was great. That was awesome. We needed to have that atmospheric correction because we are comparing temporal snapshots. But then we also needed the cloud masking, and that particular collection of data sets that did not include cloud masking. So there was another collection of the exact same images that had cloud masking, and the cloud mask itself is this algorithm called fmask, which essentially uses brightness and coolness to be able to automatically delineate the boundary of a cloud, and then uses the assumed height of the cloud and the angle of the sun to automatically delineate the shadow that's produced by that cloud. And so we used that additional band was added to the imagery when we processed it, or in the processing code in the algorithm, and then we masked all those areas out. And then the other benefit too is because we masked all those areas out and then we made seasonal composites, essentially even if there was some leftover clouds, they became a marginalized influence on the image itself because we had other images that had clear imagery in that area. But we still have some areas when you go to look at the annual maps, there are some areas that have no data because we never actually captured a cloud-free image over an entire year of imagery that happened. So.
Thanks. We have a question comment from Elliot. It says it would be fun to look at Puuvaava Forest Reserve since there has been a lot of change over the last 10 or 15 years, and we know where a lot of the change has occurred. For example, fire, niothrips, drought, silver oak control, reforestation, etc. If a place for a case study to connect forest change over time is needed, then I volunteer Puuvaava.
Yeah, I think that's actually the way that we're kind of moving. We have a publication in the works that essentially describes the remote sensing methodology and then kind of puts it in more of a broader context of land use changes in Hawaii. And the next step after that publication comes out, we really do want to start to look at additional case studies. And I will say that a lot of change is detected in Puuvaava. We do see restoration, and we do see all kinds of stuff. Actually, we can pop on the product right now. See that?
Yeah, is everyone seeing that? Everyone should be seeing the map of the Big Island. Is that, you see that, Melissa?
Yes.
Okay. So we just zoomed into the Puuvaava area. We can turn off the satellite-based map. And that's the unmixing. So this is just the Google satellite-based map that's under here, just to orient you. Yeah. So you can see with our natural eye, we can really kind of tell what is what for the most part. And then this is the unmixing. This is actually all 16 years, and Google does this thing when you have a bunch of images, it'll automatically make a mosaic, so it's kind of weird. But the cool thing is oh, this is the code that delineated the. You guys want to see what Google Earth Engine actually looks like? It's a bunch of coding. So, but we can do this. We can do this cool little thing, functionality in here, where we can do the inspector. Click here. And we can click, say, for example, right here, and we can go to the mosaic. Oh, here we go, the series. We can pop this out. And so we can see, like, for that particular, blue is grass. This is, it just automatically assigns cover, but for this particular pixel, you're going to see there's a steady grass and then woody increase at a certain time. But we can also, we have the data in here, so we can put in, this is the change to, so you can see the restoration here, and you can also see the control of trees happening here. And like, don't be judgmental of how the product actually looks here, because the change part is the part that we have to validate the most. And if we can also look at it too, like, this is woody loss, and then this is woody gain. Just completely. So I mean, the pale is very, very little, but the dark green is very high. The dark red is very high, and the pale is very, very little. So the pales are basically almost stable. But I mean, this is essentially where the restoration is happening, and we can see when we look at the pop out of all of them, that this red is the forest cover. You see this trend happening where there's a lot of red, or a lot of the forest is coming in. And you can see the same over here where you're losing, where you're controlling so you see this decline, start to see this decline in there. So anyway, that's kind of the how the product actually looks when you drive around. And this is the lower part. We start to see some grass increase. Anyway, I don't want to go too far into the changes, all of the changes we've detected, because I said
again, this is that idea where we've been trying to figure out how you establish sort of thresholds and the right statistical approach. So like, you throw all of the data at it, every single pixel in the landscape, and how does it actually, how do you like pull out those ones where you can be fairly confident that some change is happening? And that's why I think the approach that we're kind of going with now to move forward is we're happy with what the actual like raw product gives you, like what is the estimate on an annual basis. So if there's areas that you know people are interested in looking at specifically, be it a restoration site or if it's an area where they're controlling certain species, you can actually look at, you know, instead of saying how many trees would you plant, you could actually say, well, we've actually increased forest cover by X% across this area. So that's kind of the realm that we're going with this, is what we can actually start evaluating change in the landscape. Also, the big thing I think that Orlando might probably be thinking about too is like continuity of fuels. So when you start talking about, you know, what kind of percent grass cover are we looking at, and how continuous is that across that grass context. Current condition is a pretty powerful way to visualize how these fine fuels are connected across the landscape, which is essentially a simple way to indicate fire risk or fuel hazard.
Great. Well, we're about 7 minutes past 3. Are there, okay, we have one last question from Julian Dundee. Would it be possible to get a copy of your thesis to read more about your methodology? How steep was the learning curve to use Google Earth Engine? Did you know how to code already, or did you use tutorials or example codes in the engine? Do you have any broad summary data for change in the state? Well, thank you, Julian. That's a lot for Matt to answer. And I think after that, we can wrap it up so that we can let everyone continue with their afternoon.
Julian's, I know where Julian's going with this. He's like, let's do it for the Pacific.
Yeah, so as far as tutorials, you need to sign up for Google Earth Engine, but you can just go to the this user guide. When you get signed up, they'll give you this email, and this user guide has everything with coding examples of everything you need to know.
It's really well done.
It's really well done, and it's constantly being updated, and you can search it, and you can find stuff. There's tutorials. If you go through all of these tutorials, which is about 4 or 5 tutorials, and the tutorials, the cool thing is these tutorials is like, they're not like making things like, oh, this is Tulsa, Ohio, where you know you're gonna map where the road should go. This is like they're giving you a tutorial using global forest cover data from Matt Hanson's 2000, which was really kind of the breakout for Google Earth Engine, and global surface water, which was just completed from using the European sciences. These are really high-level tutorials. They're really, really cool. They go through every kind of bit and kind of using the data that is in these big competitions. So you will sign up for Google Earth Engine.
I'd also add, though, Julian, if you're interested, you should reach out to us because there's steps in the process that it's not all the code, and actually the map has this code written. There's a lot of sort of groundwork that you kind of have to jump into to do this in other islands, which would require classifying existing land cover and doing lots of these plots, which kind of set your baseline. And that stuff that is pretty simple to do. It's just the time commitment. So yeah, we can, if you're interested, like reach out to us. Let's talk story.
Yeah, totally. And just broadly, I mean, the broad cover change in Hawaii that we quantified is we saw a net forest cover gain. And it was net forest cover gain for every island, I believe, except for Maui, where we had a net grass gain. And the majority of that forest cover gain was actually happening in, the majority of pixels that we saw forest cover gain was actually happening in unmanaged areas, past, like abandoned pastoral lands, pasture lands, and current pasture lands. And we also saw the fastest rates of change in commercial forestry and in restoration areas. So that really tells us that essentially we're going through this forest transition, which is the term in land system science, where you have reforestation happening. Hawaii is going through a post-ag decline forest transition, and we're starting to see these forests pop up. And essentially, we have a choice to make of what kind of forest do we want. Do we want native forests? Do we want commercial forests? Or do we want to allow it to be alien forest? Because it's going to turn into forest if the land isn't being used in a way to not have that succession process happen.
Depending on how many fires we get.
Okay. We have a thank you from Julian. Thank you for your participation. Thanks to everyone for joining today. If you have any additional questions, comments, or suggestions for Matt, we can send out his email address again. And I guess that's it. Please complete your survey before you sign off completely. We'd appreciate the feedback. And thank you again, Matt, for joining us and sharing your project with us.
Thank you for allowing me the time.
All right. Signing off. Thanks, everybody.
All right.